This is an overview of the audio effects assignment. In this assignment, you're going to get a lot of practice with static methods as well as practice using single dimensional arrays. And so you'll be making methods that take arrays of audio samples and then manipulate them in some way and then produce a array of result values. So before I show you that, I'll show you the page in a bit, but let's have a look at my solution first. And so I've got a little different prompt here. I just colored it a little differently, and I've also knocked the prompt down so I'm typing so I don't word wrap as often. And so you can run your program from the command line. Oh, have I not compiled? Oh, yeah, audio effects with an S, I believe. Alright, if you just run Java audio effects with no command line arguments, it's going to produce a little help. And so you've got a lot of code that's actually given for you, and this is part of it. It prints out this help message. And the way this command line program works is it takes as a first argument an input file, so one of these WAV files, and then it requires you also to specify an effect. So you must always specify 2 command line arguments. And then depending on which effect you choose, there may be 1 or more optional arguments you have to specify. But let's just go ahead and run it with audio effects, and shall we play beatbox.wave, and we'll specify the effect play, which just plays it back. Alright, very exciting. We could play a different one like the cow. Alright, and so this actually play method is already implemented for you, as is the stats method. So if we run the stats method, all the stats method does is go through and loop over all those samples. And so each of these WAV files actually contains a bunch of double values, alright? Or at least after you read it in from standard in, you're going to get each audio sample represented as a double value varying between something like negative 1.0 and positive 1.0. And they're all sampled 44,100 times per second. And by playing these back, you essentially can hear whatever sound is in the recording. And by manipulating these double values, you can do various things to the audio. And the stats command just goes through and counts the number of samples, figures out how many seconds long it is based on there being 44,100 per second, and calculates some various statistics about the level. So the bigger these double values are, the louder the sound sample is. And mostly stats is there just to help you debug, so you can compare when you're implementing some of these other methods. You can compare your output with my output and see you should get the same file stats after running an effect. Let's run one of the other effects. I believe I give you the gain effect, and so factor makes it louder or quieter. So if we wanted to make the beatbox twice as loud, okay, and we'll make it into an output file, loud.wave. It doesn't play anything, it just takes this input file, doubles the gain on each sample, and then outputs to loud.wave. And if we want to hear what effect that had, alright, I can run audio effects loud.wave and then play. Okay, and so that's louder than if we play the original version. Okay, at least it's somewhat louder, or we could make it quieter. So let's do 0.2. Okay, and play it quiet. And that is the basic idea of what these different things are going to be doing. You're going to be implementing the reverse that reverses it. And so if I took something like beatbox and I can run it through my solution, if I reverse it, okay, it's just going to output the file, and then I can play it back for you. Okay, freaky, eh? That's what reverse does. You'll make one that loops, so that repeats the audio a certain number of times. Here's a version that merges the audio from several files. You can cut out parts of audio from several files, and you can add silence to the start or end, or you can also create an echo effect. And so that one's kind of cool. We could take the beatbox. Alright, and let's do the echo. Let's echo it 0.5 seconds afterwards, and we'll make the echo 25% as loud as the original. Alright, and now we can play that back. Whoops. That didn't sound like much of an echo. Let's try the cow instead. Oops. Gotta have the extension on there. Alright, did you hear the echo of the cow? And you can make it longer, so if we wanted to hear it better, we could. Where is my okay, we can make it echo 1.0 seconds and make it louder. Oops, forgot the wave extension again. And so that's basically what you're building, and let's just look through briefly the assignment page, see if there's anything important I should tell you. You download this zip file. This is going to contain some of the files you need, like standard audio. It's also going to give you a partially completed audio effects file. And so let's look at what you're going to get. You're going to get this file. Alright, here's the sampling rate constant you can use throughout your code. Audio stats is completed for you. Alright, as is audio gain. So you can kind of use these two methods as sort of a starting point and see how they're doing things. In this assignment, you're always going to be passed an input buffer of audio and maybe some other parameters, and your job is to modify this input buffer and return a result buffer without modifying the original audio sample. I've given you stubs for each of these methods. You need to fill in the to be determined portions. Alright, following the instructions in the comment that appears above it. So it's specifying things like what the different parameters are and what the return type should be. Alright, and it's also in some cases specifying what to do if the caller of your library method gives you something that's inappropriate. So for example, in loop, if they give you a, please loop -4 times, well, that's just silly, right? You don't want to loop -4 times. And I specify what I would like the method to do in that case. So this is the API. This is your contract with your client. The client's allowed to call a loop with -4, but you promise all you're going to do is return a null value. All right. And null is a special keyword, and we'll talk more about reference types in the future. But something like this array of doubles is a reference type. And you don't really have an array. If somebody gives you a loop of -3, you don't really have a result. And instead of returning a, creating a double array, all right, so if you look up at gain, where did gain go? All right, it created this result array of a certain length and then modified the samples and then returned it. Rather than do that, if they give you bad input, you just returning the null value, which is an indication that, hey, give me some more sensible input next time you try and call me. Alright, and it's the same for some of these other cases. Have several cases you need to handle. So your program shouldn't crash on bad input. It should just do as specified in the comment. If you want to use your own WAV files, you have check this out. This is the format that they need to be in. Otherwise, all the audio files provided in the zip file should work just fine for the assignment. You need to complete the audio reverse, audio loop, audio merge, audio cut methods, and then also audio pad and audio echo. And I've not even given you the method declaration for those two, and I haven't called them from the main method. So you have more work to do on audio pad and audio echo than the other methods. And I think that's about it. If you need to know how to convert seconds, if you have a sample index, right, remember this is sampled 44,100 times per second. So if you had a double array of 44,100 elements, that's 1 second of audio. All right, and that's how you can convert between indexes into your double array and times in seconds. And here are some example runs. You can test your programs on these various files and see if you're getting similar results out of the other end. And you can also try and create for extra credit, try and create an audio mashup. So use the audio files I provided and your audio effects program to make a cool mashup of audio. And I'll end just by playing part of these. This is a submission from a few years ago. Alright, so that's an example of what you can do by combining these effects in some creative way. So have fun, and good luck.